Hello, I'm going to start by explaining the first principle of derivative. So when you take the derivative of a curve, it gives you the slope of that curve at a particular point. So in order to explain this, I'm going to start by having a curve here that looks like a parabolic function, and then draw a straight line across 2 points here. So and then let's say this is with this function, y is a function of f at x. Okay, so now let's look at the first point over here. So the coordinate of this point would be x on the x-axis, and y would be f at x. And if you look at the second point, so if this is x, I'm going to draw this point down here. So let's call this distance is h from point 1 to point 2. Then this x coordinate would be x plus h. And since y is a function of f at x, then the y here is f at x plus h. So that's the second coordinate. So we can say this is x plus h. Okay, so when you find the slope of the line, you do this. Slope equals to y2 minus y1 divided by x2 minus x1, which is the rise divided by run. Okay, so let's look at the slope of this line here. So the rise here is actually y, then will be y2 minus y1. And what's y2 here? y2 is actually f at x plus h minus y1. y1 would be here, f at x over x2 minus x1. So x2 here is x plus h minus x1. x1 here says x. So let's simplify this one a little bit. So you have f at x plus h minus f at x over h, because the x will cancel out each other here. So this is the equation to calculate the slope of this line. So here's the thing. This line crossed 2 points and on this curve. It represents the average rate of change. So, and this is called the secant line, and representing the average rate of change, delta y over delta x. So derivative is to find the instantaneous rate of change at a particular point. So in order to do that, we have to take the limit of this. So let's take the limit as h approaches 0. What does that mean? Like, look at h is here. It's this distance of these 2 points. When h become closer, like it becomes smaller, eventually reach 0, it means that these 2 points will get closer and closer to each other, and that they eventually overlap each other at this point. Let's say that they're closer and closer to each other and then overlap each other at this point. So now that's another line here. So when you draw this line is tangent to the curve at this point, and this will be the tangent line. And tangent line represents the instantaneous rate of change. So this is called a dy dx. So we can say that this, as we take the limit as h approaches 0, it equals to dy dx. Okay, so this is the secant line and this is the tangent line, and they are parallel to each other. So this is the first principle of derivative. Thank you.